Over to you.
Okay. Good morning, everyone. I'm really happy to give you a quick overview of our system and our company. Today we want to discuss, or we have a look first on our company. Afterwards, we have a quick look how the freezing process is working and the defrosting process. Afterwards, I have an example defrosting, what I have for you prepared and cycle. And afterwards, we can discuss about defrosting and our machines, what we are produce and offer for you. First, Schroeter is founded 1949, and we have today around 220 employees worldwide. Therefore, we from the 220 people, we have 200 here in our production location in East Westphalia in Germany. It's in the west of Germany. We have here a production space of around 12,000 square meters. And we have two subdiaries, one of them in the USA and one in Russia. Now we have 74 representations all over the world. Our company was founded 1949 by Erich Schroeter. In the first year, he was repairing and of agriculture machines before he starts 1 year later with the first houses for smoking. 1960, he was developed a special system for smoking cabinet. This will mean it's a chain where the trolleys are hooked in and they're moved across the whole room to get an even product for smoking. In the 1970s, we start with the first exports of our machines. First export was around of Germany. Later on, we expand the export all over the world. In the 1980s, we had generation change. The son from Erich was getting to the business. In the 1990s, we did a lot of extension of our production and increased the production area. In 2000, we are developed an automatic system for with a conveyor system for trucks or for racks, for smoking, cooking, and for intensive chilling houses. In 2010, we are going more global and getting a lot of more representations all over the world. Additionally, in 2017, we did the last extension of our plan. When we have now we have a quick look on the products what we can offer to you. We have a lot of solutions for the meat, fish, and vegetable industry. First, we have our Arctic jets. That will be all the chiller, blast chillers, intensive chillers, and shower systems. Then the climate jets. It will be all systems where is cold smoking for fish or for sausages or vegetables. Then we have our semi-jets. That is a combination. It's a half continuous line. For example, a hot smoke area which transfers automatically the product to a blast chiller or intensive chiller. Our bake jet units, where we have all our roasting and baking units. The Conti jet, there we have a continuous line where you're entering the sticks directly from the filler to the machine, whereas all stages of the drying, smoking, cooking, and cooling steps are done. The smoke jets, that's our four smoke generator types. It will be friction smoke and blow smoke and liquid smoke and a steam smoke. Then we have our clean jet. There we have all our cleaning devices, and a cleaner for the exhaust. In Germany, we have here, for example, strict laws what we have to take out from our process air, and therefore we have sometimes to clean it after the processes. And we have a special line for fish. There are special designed smoke and hot and cold smoke houses for fish. And the last one, there will be our normal or regular smoking, hot smoke and cooking houses. Today we want to have a look on the climate jet. There we will find our defrosting system, and therefore, before that we can start with the presentation, I want to discuss with you first what is the thawing process. In general, it's must or should be a temperature control process. The aim is to unfreeze fresh meat, fish, vegetable, pre-cooked food or fruits, and in this step or in this process we have a phase change from a solid to a liquid. That's important to know. If we are only in the minus temperature ranges, we call it, for example, if we go from -20 to -10 for tempering, or to -8, then we call it a tempering and not a defrosting or a thawing process. Typical temperatures are from -20, -18, up to -1 to +1, +2, depends on the customer needs. In general, the thawing process is the opposite of the freezing process. When we have a look first on the freezing, there has a lot of influences on our product, what we get out after the defrosting or the thawing process. First, the freezing is a phase transition, whereas the liquid turns into a solid. The water, what is inside our products, starts ice crystallization, and the size of the crystallization, what we get during this process, depends on the speed for the freezing. And the fast speed, the slow freezing, that's in the literature written down as 0.2 to 1 centimeter per hour. That is called as a low freezing speed. On a fast freezing speed, it's higher than 5 centimeter per hour of freezing. The problem what we had is when we discussed about defrosting is when, for example, the freezing method is used as a slow one, that we have formation of bigger ice crystals. That can destruct the cells or the cell structure of our products. If we have a fast one, we have more smaller ice crystals, which allows us to have a less drip loss or thawing loss. When we have a look on, when we are speaking about freezing and thawing, it is in general a process of the transfer of heat. In the freezing, we want to take out the heat, and in defrosting, we want to take the heat in. In general, we have two principles of heat transfer or energy transfer. First is the heat transfer through the surface via convection. It will be a gas liquid, which is around the product. For example, in a normal cooler, you have an air inside where it's going through the product, or in a water bath, there will be a liquid. Another possibility will be the conduction. There we have, for example, a plate or something else where it's pushing on the to defrosted meat, but there's not normally not used in the industry. And we have a combination of it. Will be mean that we have an environment and room where we are injecting, for example, steam to have the heat source, and this going through the product, and it's circulating by an air circulation or by fans, going to the product. It's condensate on the product surface, and therefore you have the heat transfer through the condensate water on the surface. The second principle what we had is heat generation inside this product. It will be mean, for example, by microwaves. I think later on we will hear something from Siren about the microwave technology. What has some influences on the weight loss? First, we were speaking about the speed of the freezing. Here we have a chart or a picture where you can see a fast and a low speed at the freezing process. If we have lower ice crystals as shown on the left side on the picture, we will be able, the meat or the product what we want to defrost is able to take this water to its, that we have in same product what we are before we freezing in. If we don't, or if we use a slow freezing process for the freezing, we are getting big ice crystals which destroys the cells, the structure cells or cell structure, and the water can drain out with proteins and what Elna was mentioned before in the presentation, with vitamins and so on. And another point will be the thawing process itself, which have an effect on your weight loss. If you're using, for example, in water baths, you will be typically a higher weight loss compared to an air or an open air defrosting. Our system, for example, using the steam, where we're bringing in, and there we have with the high environment, with the high humidity, really low weight loss, but we can go later on this. Another important thing or point is when we are defrosting, we're speaking every time about weight loss, and important is for that we have a product what we was freezing in that is fresh and directly after it's manufactured or something, or after the slaughtering process frozen, to keep everything inside. Here we have an example of a meat block which has a drip loss before it's thawed. So it will mean that before the defrosting process or during the packaging of this chicken breast in a foil, there was a lot of drip or meat juice inside, and that was frozen between the pieces. Some customers complain about that the weight losses are too high, but what we can't do is to improve your product when it's not in good condition before it's getting freezed or before it's freezing. Here we have an example of a defrosting process which I did 4 or 5 weeks ago. Here we have the chicken breast, what we've seen before. There was the blocks of each of them of 15 kilograms. It's in a vacuum package. It was the aim to defrost the product from -18 to +1.5 degrees. That means we have to go through a phase change from the solid to the liquid. That needs a lot of energy and time. Therefore, we was reaching a process time of 15 hours and 30 minutes. And regulation, what we were setting on the house was that the surface temperature, what is maximum allowed to the product or to the defrosted good, is 4 degrees. When we have a quick look on this chart, what we generating during this process, we can see the core temperature is the light blue line. It's in the minus degrees. It's really quick when it's defrosted. if we are coming to the melting point, it's a lot of energy needed to store the ice, or to a lot of energy needed to go through the melting point. Therefore, it's really slowing down, and afterwards, when it's over the melting point, or the water is melted, it's going really rapidly with the temperature increasing. So if we have a look here on the surface, we have I start different. We was in the first stages, setting and temperature inside this room. We are injecting in this rooms and live steam. We will see on my next video it. There we have a set point here of 24 degrees. It's steam directly injected. It's increased the temperature inside the room and ensure that we have all over the process and high humidity. Here we have a probe for the surface. It's directly on the surface from the product. In general, it's between 1 to 3 millimeters underneath the surface. There we can see that if we bring this product inside of this cabinet or inside of this defrosting room, we are not directly increasing temperature on the surface. It's a little bit time. We had the heat has to go to the product, and a lot of heat is coming out of the core to the surface, and therefore it takes time until it's reaching our set point of maximum 4 degrees. Here, if we are reaching, what we can see here is when the temperature is reached on the surface, we are stopping to heating this installation to make sure that we don't overheat the products. What we can see here, this peak on the surface, is we was taking out the core probe and recollated on the piece that is not falling down. When the product's getting soft, or it's getting from the solid to the liquid aggregate, the product is sometimes moving depending on the size of the frozen goods, and therefore it's sometimes necessary to relocate the probes for the surface and to make sure that everything in the process is fine. What we can see is that the temperature inside this room was already decreased, that we don't overheat the surface or the product, that we make sure that the product is still under 5 degrees. When the air is turning, or the air is moving, the whole process until it stopped by reaching the core temperature. So I mean, if we have on the surface temperature, it's going down, for example, from 4 degrees, what we had on the surface going down to 3.5, in reason that the product giving more coolness energy to the surface, we are injecting again the steam. It's controlled accordingly to the surface. Later on, as we can see here on the third part here, is that it's not longer injected any steam. It's only by the heat what the fans bringing into the chiller, into the defrosting room. After when the core, what is wanted, is reached, that can be, for example, in the night, then we are switching over to another step where we have the possibilities to store the products. Here we have a quick video about our system. I want to show you some specific things and how it works. First, we have, or what we can do is defrosting a lot of different foods. For example, it's meat, it's fish, vegetables, or fruits. The sizes, what we can build is different to your needs. We can build in one trolley house up to multiple houses with 3 or 4 rows. There we have different options with where we put the machine aggregate, and if it's necessary to use as a transit unit. will mean that we have an entrance and an exit on the opposite side to be in a production flow. We can lift it up to a double stacked or a single stack. Normally, what we call as a standard trolley or truck is a 1 meter by 1 meter by 2 meter truck. We have different possibilities what we can do with this house or how we can equip them. In general, we have a machine aggregate where we have an air circulation and a direct live steam injection, whereas usually a cooler installed for storaging and to keep the temperature down when the surface temperature overheats. Here we have an example or in comparison from a steam application like our compared to a water bath. The main problem what we had in a water bath is that we have some outwashings of the color and the proteins. Another point will be that we have in general a higher weight loss in a water bath, and the energy cost is normally much higher compared to a directly steam injection. The reason will be in a water bath normally is every time fresh water adding. Most or the normal one are with a lot of wastewater, and that's increasing your costs. Yeah, that's for the comparison to the water bath. When we have on the different possibilities what we can build in or how we can equip our houses is that we have the defrosting function and afterward or only a defrosting function or in combination with defrosting and cooling or storage. Another option will be that we can pre-dry products. For example, if you want to defrost the salmon fillets, for example, which are already separated for the subsequent steps of the smoking, there you can laying the fish fillets directly on the shelves or mesh trays. Then we can defrost until it's reaching these temperatures. We are able to dry the product before, that you don't have any times or that you can reduce your times in your hot section. And we can do as well a combination of all three, which is the defrosting system, the drying, and the cooling. So here we can see an example installation where we have the machine on the roof with the double door for the entrance and for the left, that we don't have any backwards in our process flow. It's an option. We can have different possibilities for creation of this house. Therefore, it is possible to use an existing room with brick walls where some ceramic tiles on it, or we can offer you an housing for this machine or for this installation, or you can build it by your own by sandwich panels. The steam is directly injected. It will be sucked by the under pressure from the fan and going through to the house. Same with the temperature what is provided by heat exchanger and the cooling by the cooling coil with the referent. As a cooling media, we can use all normal used cooling media. Will be mean ammonia or Phrygen or Sole, or its glycol. We have additional in our installation probes for the room temperature, over temperature, and for the humidity to monitor all the process relevant data. As well, we have 2 probes. If it's necessary, we can equip it more. But usually we have 1 probe for the core of the product and 1 probe for the surface temperature. That allows us then a really good program or recipe following. Here we can see our air distribution on the left, and on the right side it's the inlet ducts. The fan is blowing the air and sucking out in a closed system. There is after the fan is a recirculation flap, which is changing the air from the right to the left and backwards. We have the possibility to have or to set some stop points that we can concentrate the air to specific areas inside this room and control the whole air movement. Here we have an example for a frozen salmon fillet. This customer is defrosting the product and pre-dry it in the same room before he enters to the hot smoke section. This is an installation which we did in the past. There is the housing is delivered by the customer. It will mean he was organizing and building the panels, and we was equipped this housing with our system, with the ducting and the machine aggregates. Here we have some example of frozen meat products. By us, it normally doesn't matter, is it foil around it or is it open. There we have the supply on the right and the left, and the return in the middle. This customer or this application here is with 4 probes. There are 3 core probes and 1 surface probe. The surface is putting around 3 to 1 millimeter underneath the surface, and the core probe goes directly to the core. What we see or what we have or what it looks like really easy on the video is to put in the probes. If you have frozen meat block, it will be not so easy to put the probes, and therefore the holes are normally pre-drilled with a drill. Then to close the system, there we have different options for the doors. Can normally swing door and door what we've seen like here. Now is the steam injected and the air movement starts. And as you can see, we have the steam goes all over the products and all through the products. And therefore we make sure that we are reaching all corners inside the room and all corners of the products. Here we have the machine aggregate, which is behind or in the rear of the houses. What we can see here on this product, that is when the product is coming out of the freezer or on the storage storage, we have and bring it in a warmer environment. It's the same what's happened when you're drinking a beer or a soft drink, which is ice cold, and you bring it to an hot environment. The moisture what you have or the humidity what you have in the air is directly condensate on the product. That's the same what we're seeing here. Here we have an installation with a double configuration or double stack. It's the same what we saw before. Here we have the machine. The machine is isolated, that we don't have energy losses or condensation outside of the ductwork or the ducting or the machine. That is the machine aggregate. There we have, in this example here, the cooling coil, and on the top the steam injection, and all our systems are equipped with a SIP system or cleaning in place system. different options. What we had is for our probes, how we, or that you make sure that you are using the right probe for the right measurement. What do you want for the surface or for the core? Here we have an color where it's indicated what is the surface and what is the core temperature. Here we see the same with the steam injection. So here we have an comparison from a water bath to our system, what we built. We have in our system in really good handling. It's easy to get access everywhere inside this room and to the product. We are putting the product is springing on trays or trolleys, which is going through to our house. In a water bath, you have to take it in to take it out. You can automate that, but it's a little bit less handling what we had on this system. In general, in a water bath, you have some outwashing of your colors and of your proteins and minerals, for example, and that is by us reduced. The weight loss, what we had in our for the sawing loss, is reduced by using the high humidity inside this room. We have nearly to 100%, 99 to 100% of humidity, and therefore the water, what is well, the water was inside the product, which is melting, it's staying in the product and it's not washed out. So we discussed before, the weight loss depends on the product itself, the type of freezing, and the quality of the material before the freezing process starts. With, for example, the meat juice already is existing. Typically, we have if these values here are for the range, if we are going over the melting point, will be mean to +1, +2 degrees. If we are on -1, -2, there will be less. Our houses are built, or what our philosophy is, that we are designing really sophisticated installations and which have a good sanitary design, easy to clean and to maintain, so we to reduce the sanitation costs. What we have in our system, to a quick summary, is that we have no microbiological contamination. Then we have, after every process, a cleaning process and to sanitize this equipment. The steam, what is added is microbiology, there is nothing in. So, and therefore, we don't have any contamination during the defrosting process. Therefore, we have a better food safety. And minimal weight loss, of course, due to the high humidity what we have inside our room. We have no washing out, or not directly a washing out on the product itself. We have tailor-made systems, or we offer you a tailor-made system. For example, give us room dimensions, and we discuss then afterwards with you what will be the best solution for this room, or how we can build a house for you. They're energy efficient, will be mean that we have the isolation on the ductwork and on the machine aggregate and on the wall as well. It's operator friendly. Our system, it's the PLC. You can do it by your by seeing by symbols, and going to your goal, what do you want to set on this house. We have different functions, how we can this equipped, what we've seen before with only a defrosting application or in combination with a cooling or a heating coil. We have, or on our, in general, on systems like that, is the PLC. The PLC, which controls everything about the defrosting process. We are using the surface temperature to monitor is it or is enough heat inside of this room, or if we have to add in some heat or some steam. Same for the humidity, which we are measure, and therefore that is, I would say, the heart of the defrosting room. We have additional to the PLC or to the controller, what is used inside this room. We can offer you an data recording or visualization, where every data which is, or everything what's happened or occurred inside this house is monitored. For example, all temperatures, if there are some failures, what the operator did or what he said, and there is monitored, and you can getting access, for example, from home to check is the house still running, or that you can getting a message is if you have a breakdown or the house is going to a failure. And the system is able to give some information to an HCCP system or an ERP system. Here we have once again the possibilities for how we can equip them. Only a defrosting, the defrosting with the cooling, or a defrosting with drying, or all three combined. What we can say in summary about the Schroeter climate jet, we are made or we produce the whole house here by us in Germany in our location. We don't have any producer or someone who is producing parts for us. We do it all same here. We are using in general only brand names, spare parts and parts. For example, and Bradley, Siemens, Festo, Burkhardt, to make sure that it's all their products are all over the world available, and you can replace it by your own. It's not necessary that you buy all spare parts or parts directly from us. You can buy it by your own. We have less defrosting loss compared to water baths. We have a good microbiology status that we don't have any contamination inside or during the defrosting process. We have a limited energy saving. We have flexible using of the house. It will mean we have the defrosting, we can storage or we can dry. The storage or the cooling function makes sense if you are starting the process. For example, if you have thinner products where you want to defrost, they're defrosting much quicker, but nobody else is anymore in the factory, and therefore when the defrosting process is finished, it's going directly to the storage or to the cooling function. We have 100% batch traceability with our processualization with the InTouch system. What I explained before, there we have everything monitorized from the temperature, the humidity, the surface, the core, everything. The hygienic design, there we make sure or we help to make the defrosting process more safe. In our machine, in our ductworks, where you don't have any access or a limited access, we have a cleaning system and zip cleaning installed, so that you have to start a cleaning program, and the ductwork and all the machinery grades are automatic cleaned. That's from my side, thank you very much for listening. We can discuss some points if it's necessary.
Definitely. Thank you, Jens. Thank you so much. I think the thing I always appreciate after your presentation is the precision of the Germans. And I think when you look at the design and you look at all of the controls that you've built in, it's absolutely fascinating, the extent of detail that you go to ensure that the process is under control. If I link this back to what Professor Bass said about understanding what happens to your product during the thawing process and the need to understand what happens to your product in the thawing process, what I get from your presentation is the need to understand and control the process to the extent that you've showed us in the Schroeter installations. And to me, that really talks to the validation of the control point, like Professor Bass said, and the need to be able to look at that data and know that the process is actually under control. Can I ask a couple of questions? Looking at the video that you showed us, am I correct in saying that the product was still within the packaging, so there's no step to remove the product from its packaging before it actually goes into the defrost cycle?
It's not necessary. And another point, or a good point, what we have on this is that the drip is already on the inside these bags and it's not floating away to the ground or something else. It's already there. Normally, the drip is not a weight loss. It's a mixture of the proteins and is normally used in the subsequent processes. So therefore, it gives the opportunity to reduce your weight loss a lot more.
Absolutely, that's what I understood. And then what I really enjoyed was, if I understood you correctly from the last slide, the defrosting unit becomes a chiller. It can become a chiller automatically. So if I'm using an overnight cycle to defrost, I don't need to worry about temperature abuse because it will then maintain the temperature at 5 degrees or less automatically as a part of that installation?
Sure, that we can set if we have an installed cooler or cooling coil, we are able that we have after the defrosting process to switch over directly to a holding or to a storage function, where we can set free which temperature we want inside this house. We can as well using an off fans to reduce if we have open points and out drying or something else. But it's in general, yes, it's possible to use it as a chiller.
Great, super. And then I mean, I can understand that, you know, for the likes of the escort team that are sitting in their boardroom now, you know, looking at some of those big installations, that makes sense when you're handling tons and tons of product. But the trick question is, how small can you go? What is the smallest installation that we could do? I mean, can I fit this into, you know, a kitchen environment, or does it only really work within an industrial setting?
You can put it in your kitchen. It depends how big your kitchen is. But usually I would say it's the smallest size what we can do is in one trolley. So we mean it's the trolley size will be 1 meter by 1 meter by 2. We have some option to reduce the height, but you need all the surroundings, and therefore I think it makes sense for not for a home using. It's more for industrial or for butchery. Yeah,
absolutely. But you know, in the context of food service, where you're having, you know, you've got a bulk catering environment, it still makes sense. In other words, what I'm saying is, in terms of the scaling, you can scale it to a bulk caterer, but you couldn't get one in my kitchen. I understand. Never mind, Jens. Next time I'll start working on something for domestic use. Thank you so much, Jens. And I think now we'll hold the rest of the questions to